Alright guys, welcome to the video lecture. Today we're going to be talking about earthquakes. So let's go ahead and jump on over to our notes and we'll go ahead and get this started. Alright guys, so I'm starting with a blank note sheet. You guys probably won't be. I guess we'll find out what we end up doing on Tuesday. But just in case we are, let's remember how to fill this in. Name, I'll put in my name, you'll put in yours, class, earth science, or period 1, whatever you want to put in there. The date will be 2/8/22. I don't remember what year it is. And the topic will be earthquakes. Alright, so your top should look like what mine does here. For notes, first thing we're going to put in is earthquakes. That's our topic, big and bold. We should definitely make sure that's in there. Alright, so 1. Well, what is an earthquake, right? We're going to do what we've done with everything else this semester and start with a definition. Alright, so we'll come down here, and I'm going to say that the definition of an earthquake is probably what was in your textbook, but yeah, you should have already done the key terms by now. I'm making all these videos in one day, and I'm getting confused on the order of these things. Alright, so let's go ahead and go to your textbook. I went ahead and pulled up your textbook, and like I went through with the key terms video, this little section right here, where it highlights earthquakes, that's where it's going to have the definition of an earthquake, and that's what we should use, obviously. So this paragraph says, rocks usually change shape or deform slowly over long periods of time. Alright, well that doesn't quite sound like the definition, but it's part of it. As they're strained, potential energy builds up in them. Alright, well what's potential energy? There's two kinds of energy. There's potential and there's kinetic. Well, there's a lot more, but those are the ones we're worried about. Potential and kinetic. Kinetic is if I were to pick up this rock and drop it, it would start falling. It would have kinetic energy. But while I'm holding this rock up here, it has potential energy. It has the potential to fall and use that potential energy as kinetic energy. Alright, so similarly, these rocks, as they change shape and deform, they have potential energy in them because they're straining. They're pushing against each other. My hands, you can see they're shaking a little bit. They've got potential energy because they're pushing against each other, but they're not moving. All right? This energy is released suddenly by the action of rocks breaking and moving. Such breaking, sounds like it's about to be the definition, and the movement that follows causes vibrations that move through rock or other earth materials. If they're large enough, these vibrations are felt as earthquakes. All right, well that sounds like a pretty good definition to me. So potential energy builds up in rocks and is suddenly released by the breaking and moving of the rocks, which causes vibrations to move through other rock and earth materials. All right, so let's head back to our notes. So we'll say potential energy builds up in rocks, and what else did we say? Let's go back to our notes. And when they finally break, the energy is released in motion and vibrations. If the vibrations are strong enough, it is an earthquake. All right, so let's think about that. If the vibrations are strong enough, well, we can cause the buildup of potential energy, the release of it into kinetic energy and vibrations. Really easy. If you can snap, please do so now. No, for real, you're probably sitting in class, but if you're watching this, snap. It's gonna be really random, there'll just be a spattering of snapping, but try it. I'm gonna take my thumb and my middle finger. I'm not gonna put just that up, obviously. Come on, what did you think? You were gonna trick me? All right, I'm gonna put them together. Right? And I'm going to press, and I'm going to press, and I'm going to press, and I'm building up potential energy. And you are too if you're doing this with me. And then finally, it snaps. Probably couldn't even hear that. That was lame. There we go. That's a better one. All right. So the middle finger comes down. It's moving, it's moving, it's moving, it's moving, and then it hits right here. And then it makes a vibration. That's what the noise is, going through the air. All right. But that's not an earthquake. That was super weak. It's got a nice snappy sound to it, but it's not strong. All right, it has to be vastly stronger to be an earthquake, and we'll look into just about how strong later. All right, so we've got our definition down. Let's go ahead and add another part to this. We'll add the example of snapping. So real life example. And you guys can be writing or typing this, whatever works. We'll come down here, real life example, snapping. The buildup of potential energy moves into kinetic energy and vibrations. In this case, sound. All right, cool. So now we're all making our little mini earthquakes in this class. It's a good time. What else can we talk about? Well, we could talk about where this happens. So, where? Let's come down and add another point. All right, where do earthquakes happen? Take a wild guess. Fill it in before I even say. Pause the video if you need time to think. It happens at plate boundaries, right? We talked about this. The plates are moving. They're moving into each other, away from each other, right beside each other. All kinds of different motion, right? Well, when they're moving, sometimes they get caught. You can think of it like gears, right? The one moves and it moves the other. But what happens if they're moving in opposite directions? Well, they're gonna move and move and move, and then they catch, right? And one of those gears has to break. Either break a piece off or break in the center where it's actually turning from. It's gonna have to break somewhere. And that's exactly what's happening. They're breaking the rock apart. Our book even said that right here. The energy is released suddenly by the action of rocks breaking and moving. All right, so where do these happen? Plate boundaries, where plates are moving where? Right, because we said that there were different kinds of motion, so are these happening where plates are moving past each other? Yeah, I think so. You could have like a little lip that gets like caught and doesn't want to move, and then suddenly there's an earthquake. That'd be like the San Andreas Fault, right? We talked about how California, part of it was moving north and part of it was moving south. All right, so they're moving across each other. What about when plates are moving apart? Probably not. There's not a whole lot to get caught on, right? They're actually making room for each other. They don't want to be anywhere near each other. So not that one, which leaves us with just when they're coming together. Well, when they come together, they either have to go up or down. What if they want to fight for that? What if one doesn't want to go up, or what if one doesn't want to go down? That can become a pretty big issue, right? They're going to fight and fight and fight until one finally slips over or slips under, right? So towards each other. And across maybe isn't the best word. That kind of implies that they're like on top of each other and like moving across each other. So let's say moving past each other. That'll be better. All right, let's go ahead and add another point to this. All right, let's talk about the actually fun part. What the heck happens during an earthquake? We've talked about the where, let's talk about the what. I typed where again. What happens during an earthquake? Put in your guess. Pause the video, put in your guess. We'll talk it through, but you guys know what an earthquake is. All right, so the first thing that's gonna happen is the ground's gonna shake, obviously. We just talked about this. The earth is gonna break. It's gonna be released in the form of movement and vibrations, okay? So vibrations, right? And that's an earthquake, boom. Once it starts and stops vibrating, that is the earthquake in its entirety. But that's not all that happens, right? After that, a lot can happen, all right? So what if it vibrates really hard and a building collapses? Maybe it's your home, maybe it's a school. Well, if buildings can collapse, don't you think other things could collapse too? What about trees or dirt? Kind of sounds dumb to say dirt, but like if it's a hill, right? You've got a hill and it starts shaking, some of that dirt might fall down. Now you get enough dirt high enough up, suddenly you've got a landslide. And if we are knocking down trees, hey, trees have roots, right? And if trees have roots, then they're like holding the ground together. You knock a tree over, ground isn't as held together anymore. So if we start knocking down trees, especially on a hill or a mountain, then a landslide becomes a lot more likely. Now what happens in a landslide? Things get buried. So earthquakes are burying things. That'd be unfortunate to survive an earthquake only to be buried by a landslide. Hey, what's one thing we noticed about our tectonic plates when we were looking at the boundaries? They were kind of on the edges of coasts most of the time, right? Like continents were kind of in the middle, and then most of the boundaries were on the outside of it. Yeah, well, what's on the outside of continents? Ocean, right? Well, if we're vibrating the ocean, what's going to happen there? And you guys already know the answer to this. We've talked about it, but let's bring it up again. Tsunamis. Waves are just little vibrations, right? I mean, we look at sound waves, right? Sound waves are vibrations, but what was the second half of that word? Waves, right? They move in a wave-like pattern, and so like top, bottom, top, bottom, top, bottom, top, bottom. That's the vibration, right? But it's also moving over time, and so waves are vibrations. We get a really big vibration, we're gonna get a really big wave. So tsunamis. Tsunamis are gonna cause flooding. They're gonna cause water damage, obviously. And they're gonna cause, I don't know, what else are they gonna cause? I can't think of anything off the top of my head, but if you can, feel free to add it. All right. So I think that's all that I wanna add to the notes section of this. We've got 4 points here. What are we gonna add in the diagrams? All right. I'm not gonna draw them on here because I'm on computer, but here's what I want you to do. You can finish up this video and you can add in these things. I'm gonna type them out. All right, so the first thing I wanna say is plates building up potential energy. And here's how you're gonna draw that. You're gonna draw 2 plates pushing into each other. All right, so you'll have one arrow going this way and one arrow going this way. I'm looking off to the right because that's where my recording is. I can see myself. All right, so you have 2 plates coming together. One arrow this way, one arrow this way. And then you're gonna draw a second set below it. And you'll draw a bigger arrow this way and a bigger arrow this way. All right, so we're building up potential energy. And then what I want you to do is draw one plate that moved. All right, it's gonna bend up. And then I want you to draw like little arced lines, sort of like a Wi-Fi signal, like coming out on the top and on the bottom. There's energy being released there. There's vibrations being released there. All right, so we're building up potential energy. We have small arrow this way, small arrow this way. It gets bigger, big arrow this way, big arrow this way. And then it breaks and we get our earthquake, and we're gonna draw that, okay? We don't need to draw anything for our real life example. You can just snap and remember it. Don't need to draw that. And by the way, if you guys are snapping during your test, like, don't let it get excessive. But if you need to like remember, oh yeah, that's that process, totally cool. All right. And then let's remember these 2 important things for what's happening. All right. Obviously there's vibrations. We just drew that. Obviously buildings can collapse. We like conceptualize that when we think about earthquakes. I want you guys to draw a landslide and a tsunami. So I want you to draw like a hill with a bunch of dirt falling off of it, dirt and rocks. Maybe draw like a little hill here with a house at the bottom and then some rocks falling towards it. Label it landslide. And then below that, draw like a little coastline with, again, maybe some houses there and a giant wave, and label it tsunami. All right, and those are gonna be your causes and effects of earthquakes. The potential energy buildup, the vibrations, the waves, and the landslides. All right, once you have all of this written down and your diagram's done, that's it. Thanks for making it through that with me, guys. I really appreciate you pushing through, getting these notes down, really learning the material, doing the demonstrations with me, and figuring this out. It means a lot. Be sure to check this with me in class. Show me your notes that they're done, that they're filled in. I can clear you to move on to the web quest. Thanks.